All right, we're live. Okay, what are we going to talk about today? We're going to talk about the impact of El Nino and the expectation that the world is about to go over, because of El Nino, that the world is about to go over the 1.5 degrees C above baseline target. One of the targets set by the Paris Climate Accords, and the other target was 2 degrees C above the pre-industrial temperature baseline. So these are, once again, these numbers don't sound like much, right? Is it 1.5 degrees? Wow, big deal. Well, first of all, it's 1.5 degrees centigrade, and that's, you know, 3 degrees or 3.5 degrees Fahrenheit, do the conversion. And it's global. So it's always going to be an average. You might not have a whole lot of extra heating or excessive heating in one part of the planet, but you might have a tremendous amount in some other part of the planet, and it ends up being an average. We already know that the poles, the South Pole and the North Pole, are heating up more. I guess that's the best word. Are experiencing more heat accumulation than, say, the equator. This is well understood. And it's too bad, of course, because there's nobody at the poles really to notice what's happening. The few people that are up there, don't count, which is a really sad reality. For people living at the North Pole, there's no one living at the South Pole except penguins, and they really don't count. They're having problems. So the changes elsewhere in the world are more on a gradient. So it's an average. It doesn't sound like much, but it's affecting the entire Earth system. And the problem with messing around with the Earth system is we don't really understand it, and we don't really know what to expect from the entire Earth system: the atmosphere, the cryosphere, the biosphere, the hydrosphere. We don't really know what to expect from these components of the Earth system when we start bunking around with a fundamental lever, gear, whatever you want to call it, like global temperature. We kind of know what impacts what happened, but we don't know what will happen to the system. Okay, it's real easy to lose track that we're not changing temperature, because none of this happens in isolation. It's like if you got a virus and you got sick and you perspiring and you felt weak and you lost your appetite, and your temperature would probably go up, right? You get a fever. Oh, I got a fever. Take some aspirin. And okay, but that's just one manifestation of your entire embodied system, right? And a virus can raise your temperature, but it can also cause swelling in the brain, and it can destroy your liver. And if it's something like COVID, it could attack all of the organs. Attack all the organs in your body, and cause all sorts of system level problems. Right? All we notice is you have a fever, and we could treat your fever as a symptom. But the truth is, your entire system is probably under attack. So it's the same thing with these temperature changes. We're injecting CO2 in the atmosphere. It's changing the temperature. Okay, these are some things that we understand. We can measure one and infer the other, or whatever. But it's not a system view. So getting back to El Nino, El Nino is one of the two phases of what's called the ENSO, the El Nino Southern Oscillation. It affects the South Pacific, mostly equatorial Pacific. And you can find out what the El Nino and the ENSO is about, and that's fine. But what it does do is it shifts an area of really hot water, and it spreads it out across the equatorial Pacific. And in the process of spreading that hot water out, it submerges an area of cold water that is normally located off the west coast of, say, Central America. And it submerges that cold water. So now the area of hot water is bigger, and an area of cold water is missing. And what the impact of that seems like a small thing, but the impact of that is, well, there's many impacts. There's impacts on the biological functioning there. The I don't want to talk about that, even though I'm a biologist. I would like to, but I'm not going to. It impacts weather patterns, and it turns out it impacts weather patterns over most of the planet. It's crazy. Scientists are only just recently discovering all what are called teleconnections, distant connections, where you know, pushing a little hard over here causes something over here to pop out, or moving this thing a little left moves this other thing a little right, and it's subtle, and we wouldn't even know these things if we didn't have really powerful instrumentation, both satellites and on the ground, all over the world. If we couldn't see the entire system, then we wouldn't understand any of this. And prior to having all that instrumentation in orbit, on the ground, on ships, in cities, in the country, prior to all that, we had no idea what was going on. So now we're, for better or for worse, we're kind of catching a clue. And so the El Nino right now is going into the ENSO is going into the El Nino phase, which is the hot phase for that part of the Pacific Ocean. It's raising the average temperature of the planet because the temperature of the oceans do count a lot for the temperature of the planet. The temperature of the planet, starting with the oceans, was already at record levels. People were saying before the El Nino phase started that the oceans were extremely hot, hotter than they've ever been seen in the instrumental record. And that's saying something. It may not mean anything to you, but for people who care about data and who are watching trends, long-term trends, trends long-term being what, 70 or 100 years, people are watching long-term trends, care about these things, and they notice it and they can become alarmed. And they've been saying for a good part of a half a year now that we're in big trouble. The oceans are getting hot. Now, you need to understand the oceans get hot, they stay hot. They just do. And then the ENSO is swinging, which is a natural thing, between La Nina, the cold phase, and El Nino, the hot phase. So people have been kind of wringing their hands, wondering what was going to happen in this scenario where the ocean's already at a record temperature. And now we're going into the El Nino phase, which tends to make the whole planet act like it's hotter. The jury is still out. We kind of don't know. We've been seeing really wild weather phenomenon. It's really crazy. It's just scary, crazy what's happening in the world right now. The planet is getting hotter. Now, the planet is getting hotter because of atmospheric CO2 concentrations, which are not going down. Our contribution to the atmospheric CO2 parameter is not decreasing. We're adding more, and we're adding more, second order more, every time they check it. And now the El Nino comes along. So we're in this really interesting place. We're conducting an interesting experiment. We've got this Earth dynamic system that's been kind of stable, for a couple thousand years, I guess, and reasonably stable for 20,000 years, during which, enjoying all that stability in the weather and in the climate and whatnot, we were able to create civilizations. We were able to create, coastal cities because the sea level wasn't changing very much. What it can do, the sea level can change a lot, really, I mean, hundreds of feet during ice ages. So it would be really difficult to establish coastal civilizations, which is where all civilizations kind of start, is on water, rivers, seasides, or a combination of the two. And it would be really difficult to do that if things weren't stable. So things have been stable. Sea level is mostly stable. The rain regimes, the cloud regimes, the hot and cold of the seasons has all been relatively stable. And so during that period of stability, we were able to explore the planet, move around. We had kind of free access to everything. There wasn't a lot of ice. It wasn't dangerous to be on the seas. There weren't these cataclysmic storms that would blow up because of changes in temperature. Things were pretty stable, and we're kind of experimenting with that now. We're moving it into a different regime, and that regime is of temperature at least, and that's not going to be stable, is what we call astable. So it might oscillate back and forth around wherever we're pushing it. It's going to like to come back to where it was, but it can't because we're pushing it. We're pushing it. We're pushing the system. We are pushing it by constantly increasing greenhouse gases in the atmosphere. We're pushing it by accelerating the way we increase greenhouse gases. So it's a second order push. We're pushing harder every year. It can't even settle down. It can't even reach a new equilibrium. We're always 20 years behind. And it won't start to equilibrate to a new set of conditions until we stop doing what we're doing, which is burning fossil fuels and dumping the CO2 and methane into the atmosphere. So we are now reaching, because of El Nino and the overall heating of the earth, plus the El Nino heating, the extra kick that we're going to get for the next 2 or 3 years, we are approaching 1.5 degrees C above baseline. We have been kind of knocking around 1.1, 1.2, always going up 1.3. But people were saying, oh, 1.5, yeah, we'll get there someday, but it might be 20 years down the road. Well, surprise, surprise. The estimates now are we're going to reach 1.5 soon. If not, we haven't, maybe have already done so. So all the prognostication that, well, we've got 20 years before we reach something that we consider to be a bad number. Well, check your watch, because in the next couple of hours we might do it. And then my wife was reading an article and she related this to me, and I was saying, oh, Katie barred the door. We're in for it now. There's now an estimate that because the El Nino is going to continue and get more pronounced, or worse, if you'd prefer, more pronounced in 2024, that this is going to ratchet things up even further. And we might find ourselves hitting 2.0. Now, at the Paris Climate Accords some years back, they said, they set this aspirational goal that we should not exceed 1.5 degrees C above baseline, because that would be pretty bad. But 2.0 is just a drop dead. Do not cross go. Do not collect 200. If we get to 2.0, we have really screwed the pooch. Well, now they're saying we might get to 2.0 this summer. Now, being very careful here, that's during an El Nino. The El Nino is a natural oscillation from a cold phase to a hot phase and back. Okay, so when the ENSO, the El Nino Southern Oscillation, when it drops out of the current warm phase and swings back into the cold phase, some of that heat will be drawn back into the ocean where it kind of came from. Okay, the cold water will resurface, the hot water will be pushed back to where it was before, and the overall temperature of the earth will appear instrumentally to go down a bit, right? Now, that's sort of a, so first of all, getting back to the title of this video, that's an experiment. That's an experiment. We've never been at 1.5 degrees above pre-industrial baseline. We've certainly never been 2.0. And we kind of don't know what will happen when the El Nino swings back to the colder ENSO phase, which is La Nina. We're kind of assuming, oh, well, that temperature will just kind of drain away. But what if it doesn't? What if on the way to 2.0, I'm not sure how to say this. This is an Earth system. This is a big geared clock. It's got all these gears, and they're turning together, and they're meshed together, and there's millions of them. There's millions of gears in motion in the Earth dynamic system, and we've just taken one of those, well, two of them, the CO2 levels in the atmosphere, and then the gear that it turns, which is the global temperature. We've just taken those and sent them through a whole nother set of gyrations. And now we're going to sit back and look at the machine. On our way to 2.0 during El Nino, we might trip over something. We might break something. We might find that there is another gear over here that we didn't even know about, that if the Earth system, for any reason, exceeds a certain threshold, which, just look at the weather. I mean, we're obviously playing with fire here, literal fire in some cases, okay? if we push the system too hard and we get over a certain point, there may be something that breaks maybe in a temporary way, but maybe not, because we don't know. This is all new to us. We have no experience with any of this. We are conducting a global experiment on a system that we don't even understand how it works. We have no comprehension of how this thing works as a whole. We understand this bit and this bit and that bit, and but we don't even know how many parts there are to this giant engine, and we don't even know what happens if we push any of them or lose some of them or let some of them fall out, or we don't know. We just don't know. We're conducting an experiment. It's like revving up some engine in a car to red line and just keeping it there, and then to see what will happen. Will it blow up? Well, what if we drain the oil out? Well, then will it blow up? What if we, let all the water out of the radiator? Will that blow it up? Let's see what happens. Let's do an experiment. Let's just rev this engine as high as it'll go, and then let's take the oil plug out, let the oil run out. Okay, that's the kind of experiments we're doing. And with a car, it's pretty simple. We know that a car engine needs oil and it needs coolant, and we know what'll happen if you drain those things away and you're running it at high RPMs, which kind of know. But with the Earth system, we don't know anything about it. It's like we're a 4-year-old, and we have now this engine that's revving at high revs, and there's something that we can take and undo, and this black liquid comes out. Well, that was cool. This stuff is kind of hot. It's kind of slimy. What is this stuff? And we don't know what we just did. We're toddlers. We're toddlers. We're messing around with a motor, and we're toddlers. We pull wires out, pull out hoses, let things drain out of the engine block. We're toddlers. We don't understand any of this. Yeah, so El Nino has come along. We know that it does that. It has a little kind of a pendulum swing that the ENSO goes through these extremes. We know we're going into an El Nino. We know that the Earth is abnormally warm, abnormally hot. It will never cool down from what it was. And now that it's going into an El Nino phase, it might not cool down from that. You see, we just don't know. It's an experiment, but we're toddlers. We're chimps. We don't have no idea what we're doing. So they, it's El Nino is causing it to go over 1.5. Don't worry, it'll swing back into the La Nina phase, and then the heat will drain away, and it'll be fine. Don't worry. Pat yourself on the head and go sit in your corner and play with your blocks, okay? And they don't know that. They don't know that. They would like that to be true, but they don't know that. You understand? You understand the difference? They would like to think, oh, yeah, well, it's the El Nino that's doing this. And when it swings to hot, well, then you see heat. And it goes over to 1.5, and then it hits 2. Maybe it hits 2.5. Who really knows? But it doesn't really matter, because El Nino is a cycle. So it's going to swing back, and then all that heat will drain away. They don't know that. They don't know that. Because we're playing with the system we don't understand. We just don't understand. So I guess we'll find out. That's what happens when you do an experiment where you don't understand what you're doing. You find out, right? Right? You find out, and you may not like what you learn. Scenarios. I'll give you one. Let's say that it gets so hot during this current El Nino phase. It gets so hot that ocean circulation patterns change, and the Arctic Ocean gets really hot, and there's so much latent heat in the Arctic Ocean at the North Pole that it makes it harder for ice to form, both in the water and on the land. And then that decreases what's called the albedo, or the reflectance of the surface. So now when you get a summertime in the north and your days last 24 hours, right? So the sun is up above the horizon for 24 hours at a time. There's no albedo. All the ice is gone because the ocean just got so hot. Remember, everything in the North Pole is amplified. So if the global average is 2 degrees above what we kind of had been experiencing, then in the Arctic, the temperature might be 8 degrees above what we've been experiencing lately. It could be a 4x multiplier. I don't know that, but no one else knows that either. It could be. And if that's the case, maybe all the ice melts. And then for a year or two after that, no ice can form, or very little. Maybe it's very loose and slushy ice, and it doesn't form sheets of ice that can hold the hot water down and reflect the light from the surface. And maybe it doesn't snow anymore in the Great North, in the Canada North, or Siberia. Maybe it doesn't snow anymore because the water is too hot. There's lots of water to evaporate moisture and it goes into the atmosphere, but then it comes down as rain. And it rains in Canada and it rains in Siberia and it melts all the permafrost. And then the permafrost is warm and melting and it's spewing out methane for a couple of years. And there's massive influx of methane into the atmosphere, which then basically throws another wrench in the machinery. And pretty soon, even though El Nino goes away, there's been so much disruption of the cooling system of the planet, so much disruption, so much damage, that when the El Nino swings back to the La Nina phase and drains some of the cyclical heat away, the planet doesn't cool. What if the planet just can't cool? There's no ice in the north, and there's all this methane been shot into the atmosphere over a couple of years, and people are looking at the Earth average temperature and the temperature distributed over the planet's surface, and they're saying, "Oh my God, oh my God, oh my God, we went over 1.5. It's permanent. It's never going down." And they were saying we won't go over the 1.5 degree target for 30 years or 25 years, and we went over it 25 months later. After they said that we couldn't do it for 25 years, 25 months later, we did it. We don't know. We just don't know. We don't know. This whole dumpster fire could just take off and just go somewhere because we don't know how this works. We're toddlers messing around with a machine that we don't understand anything about. We know there's a thing that turns, and we know there's things that make a noise, and it's all fun to watch. And and then we start pulling hoses out and pulling wires out, and doing the oil pan, and we're just kids and we don't understand what's going on. We're children. Well, we're going to find out, aren't we? We're going to find out, and that's too bad. We didn't have to do this to ourselves. We could have said, "Wow, excuse me, but I think we're messing with something we don't understand. Maybe we should just back off." How about that? How about we just back the fuck off and just stop this? Oh, well, that would mean reducing or eliminating CO2 emissions in the atmosphere. Oh, that seems simple enough. How do we do that? How do we reduce or eliminate CO2 emissions into the atmosphere? Could you explain that to me, please, good sir? Because I'm really interested in that. Oh, we have to stop burning fossil fuels. What? Well, we can't do that. Well, that's how you do it. That's how you stop emitting CO2 in the atmosphere, is you stop digging up and setting fire to fossil fuels. And you probably shouldn't set fire to forests either, but that's the carbon cycle. So that would probably sort itself out. But in the short run, it does not sort itself out. So you should probably stop setting fire to forests, and you should definitely stop setting fire to fossil fuels. And that means leaving them in the ground. But we didn't do that. And we can't do that. Sorry. So we're going to start running this thing off the rails. And because of the really high temperature on the planet right now, due to all the heat in the oceans, and then this El Nino swings into action, and we're going to go over 1.5, and then we're going to go over 2.0. And who knows what happens when all that's going on? Who knows what we're going to do to this thing? And my recommendation would be get ready for some surprises, people. It'd be nice if we didn't have any, but get ready for the surprises. Well, that's enough of that. I might have more to say on that later, but for now, I think I made my point.